we're going to look specifically at the ecosystem in the coral reef, and they're going to have lots of different animals, and it's going to talk about. And so I've got these, and so this is like, have you guys seen flowcharts or something like this? You know, with arrows, and you've seen like different charts, right?
Yeah.
Yeah. So this one is showing how the energy flows in the system. So it goes from the sun to the plant cells inside the coral, to the coral organisms, to the parrotfish, to scavengers, right? And so these are 3 different ones, and the video is going to talk about this. So as you're kind of watching the video, you can fill in these boxes, and you can do it after the video. Okay. And we can watch it more than once if we need to, but you can fill in these boxes. Are these things producers, consumers, or decomposers?
But at night, the polyps extend their tentacles to feed on plankton, tiny organisms that drift in the water. Meet another creature that feeds on plankton. The spiny blenny watches for plankton that may drift close enough to be snatched and eaten. When this parrotfish takes a large bite of coral rock,
were there any that you guys were like kind of questioning? You weren't sure about?
The parrotfish.
The parrotfish. What? I saw you had another answer down, right?
Mhm.
Yeah, decomposer. So the parrotfish is eating those coral organisms, those little creatures that came out at night.
Mhm.
So do you think that are those little creatures, are they living that come out at night?
Yeah.
Yeah. So if it's eating living things, what do you think it is? Consumer or decomposer?
Consumer.
Consumer. Yeah.
That's why I changed it.
That's why you changed that. So you can see in this coral, right? We got all these different things that all sort of depend on each other, right?
Mhm.
Without the fish, then what would this great barracuda eat, right? Or without the sun, how would we have these little plants, right? So
here they are. If coral reefs are under too much stress, like in these conditions, they can eject the algae living on them and turn completely white. This is known as coral bleaching. This does not necessarily mean...
You guys can try this. You can adjust the water temperature and how much pollution there is, and then we'll start the storm and see what happens to this coral. So see how the coral is now? All right, how about Ava, you can do one, and then Shay, you can do one, okay?
Okay.
So yeah, you can do it a few times. You can do it wherever you want it, from less to more. And then the water temperature, how you want it.
Okay.
And then start the storm. Dun, dun, dun.
It's all white.
It's all white.
It's bleaching.
So that means what happened to the algae?
The water temperature got too hot. Well, it started bleaching.
Bleaching. So there's no, because algae's kind of like colored, right? Green or whatever. So there's no algae on it. Oh my goodness. All right. Shay, you can give it a try. You can think about how change could affect an ecosystem. So what would happen to all these different animals? You can look at this if you need to remember some of the animals. What would happen to all the different animals living in the ecosystem if the coral were to eject the algae? If there was no more algae, what would happen to those animals? So maybe you could write about a specific animal, what would happen to them, or think about how that affects the rest of the ecosystem and write. What did you say?
I said that most of the animals wouldn't survive because they would have less food and not a home, and but the producers would stay alive longer because they live off of the sun.
Yeah. So maybe other producers besides this algae, they could survive. Yeah. Did you? It reminds me of the part where the video where they said that if the sea urchins weren't there, that the algae would just like overgrow. You kind of need these things balancing out, right?